Hello everyone. Today we'll be solving stars drawing, right? So this was asked in the Codeforces around 501 for division 3, right? So let's see what the question states. So before that, you can just go through the question. It's very easy to understand, right? So here to here, it's very easy to understand basically. So I'll just summarize the question so that it will be easier for us to solve the problem, right? So now let's see what the question states here. So we are given an n into m grid, right? So just give me 1 second. Yeah, we are given n into m grid with star and dot, right? With star and dot. This one. Just consider dot, right? So we are given n into m grid with star and dot. A valid star has a center star. A valid star has a center star. Center star should be present, right? A valid star has a center star and four straight rays. Up, down, left, right. Four straight rays, right? I'll just give you four straight rays. If SR means four straight rays, right? So this has to be up, down, left, and right, right? So again, a valid star has center star and four straight rays up, down, left, and right of equal positive length made of star. Of equal positive length made of star, right? So we can use any number of stars. They may overlap as well, right? So we can use any number of stars. They may overlap as well. Our goal is to represent the entire star pattern using stars only. What is our goals? So our goal is to represent the entire star pattern using stars only, right? So or print -1 if it's impossible, right? Or print -1 if it is impossible, right? I'll just give you impossible, right? So just keep this in mind. This is also one of the important right cases. We have to print -1 if it is impossible, right? So constraint here is each star must lie fully inside the grid. We don't need to minimize their count, right? So again, the constraint part here is each star must lie fully inside the grid and we don't need to minimize their count, right? So this is the question. So let me read this one again loudly. Just listen to this. We are given an n into m grid with star and dot, right? So a valid star has a center star, this one, and four straight rays, and four straight rays, nothing but up, down, left, and right of equal positive length, that is made of star. Again, that is made of star. We can use any number of stars and they may overlap as well. We may use any number of stars and they may overlap as well, right? So what is our main goal? We have to represent the entire star pattern using stars only, right? So we have to, what we need to do, represent the entire star pattern using stars only, right? Stars only, and we have to print -1 if it is impossible, right? So we have, our main goal is to represent the star pattern using stars only, and we need to return -1 if it is impossible, right? So what is the constraint here? So each star must lie fully inside the grid and we don't need to minimize their count. So this is the constraint, right? So I'll just give me a second here. Let me remove this one. Let's come to the input output part. I hope the question part is completely clear, man. You can just go through that again if you didn't understand, right? So I'll just leave it to you. So now let's come to the input output part here. So this here they have represented by 6 and 8, right? So you can see here there are six inputs that consist of the dot and this one stars basically, right? So 8 is the this one number of dots and stars. See here 1 2 3 4 5 6 7 8. Same goes with here 5 and 5. So this consists of the five inputs. See 1 2 3 4 5, and it consists of five this thing. The input, it has to consist of uh, the number must sum up to 5. Either it can be of dot or stars. Here see here 1 2 3 4 5, right? 5 5. So the output that we need to get here for the first one is this one. Output we need to get here for the second one is this one, and third one, fourth one. All right, so for the third one and fourth one it is impossible, so we have to print -1 man. So how we got the output, that we'll be discussing in the approach. I'll just consider the first example for the approach, right? So you can just try it out in the same way for the example 2. I insist you to try out for the second one that we discuss by considering the first one, right? So I insist you to try out for this for the second example in the same way, right? So let's do one thing now. As we are completely familiar with the question and the this one, what do we call, input output, let's discuss the approach, right? So first let's discuss the approach followed by the complexities, and then let's write code, then let's write the code, right? So initially, as usual, let's discuss the approach first. So let's consider the first example, the same example, first example that they've given in the question, right? So we have already discussed this one. This one, six inputs, right? One, two, three, four, five, six here, eight here. This consists of, when we sum up, it has to be eight. See here, one, two, three, four, 5, 6, 7, 8, right? So this is the main, this one example are the input. So this one, the output that we need to get here is 3, 3, 4, 1, 3, 5, 20, 3, 5, 1. This is fine. Let's move on with the step-by-step explanation, man. Let's go with the DP idea. The first thing I want to tell you here is we will be going with a 2D DP table, or 2D dynamic programming, right? So just remember this, we'll be going with a 2D dynamic programming. So how we will implement the DP? Let's see that, right? So here, let me go with the step-by-step explanation. This is nothing but the DPI idea. In short, I'll explain in short, right? So here, for every cell, for every cell, this one, for every cell here, these things, right? For every cell, we will pre-compute how many consecutive star we have in the four directions, including the cell. So we can consider, for just for example, we can consider this one, this one, this one. This is consecutive, right? Either we can go positive, this one up, either we can go down, either we can go left, or we can go right. We cannot go diagonally, right? So they have mentioned in the question, either we can go up, left, right, or this one. If we start from here, star, we can either go with this one, down, left one step, right one step, and up, like that, right? So how many consecutive star we have in the four direction, including that particular cell, up, down, left, and right. I hope this part is clear, simple, right? So center detection in the sense, a cell R comma C can be star center with a size this one. Basically, S equals min of up, down, left, right minus 1 if S is greater than 0. Just remember this one. We'll be making use of this one in the code. So you'll get to know why we have done this one, right? While writing the code, basically, right? So we have went with S equals min of up, down, left, right minus 1. So this is kind of formula basically for the center one, right? So here, a cell R comma C can be star center with size this one. S equals min of up, down, left, right minus 1. Right. Then we have to mark the coverage, means here for each detected center and S cells along each direction as covered. Right. So what we are doing here, we are marking coverage for each detected center and S cells along each directions as covered, right? So this is fine. Now let's go with the validation part, man. After processing all the centers, if any star remains, so if any star remains in the this one grid, that remains uncovered, we have to give the answer -1. Answer is -1, right? Else we have to print all the stars. We have to print all the stars. So this is what we'll be doing, right? So after processing all the centers, means the stars within the center, means the star remains with the star which remains uncovered. So for that one, we will be going with the answer -1. Else we will be printing all stars. Else we will print all the stars. Right. So this is fine. Now let's move on with the next one. Let's consider the first example. Same thing, right? So first we have here 6, 8, that one dotted star. So this one, basically I'm speaking of the input, this one, man, this one, right? So let's consider this one. Now we have 4, this one, fifth star, 6, 7, 8, this one for the first input. Second input, same goes with the second input, third, 4, 5, sixth as well, right? 6 lines we have. So DP fills, see example here, we have considered 3 comma 5. Just give me a second here. So this one is represented in the form of gridman. Just don't remember. So try to remember this one. Whatever we have written here, 1, 2, 1, 2, 3, 4. So this is 5, 6, 7, 8. So we have, uh, this will be actually 6 into 8, right? So 1, 2, 3, 4, 5. So this one 6. So we are considering 2D DP table here. So don't forget. So this will be starting from 0 comma 0. right? So this one will be 1 comma 0, this one 2, this one 3, so on 4 5. So the final one will be 5 comma 7, right? So final one will be 5 comma 7 basically, right? 3 comma 5 comes somewhere in the middle, this one center, right? So this one in the center, 0 1 2 3, this one 3, 3 comma 0, 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 5, 3 3 0 3 0 3 1 3 2 3 4 3 5 is this one actually, 3 comma 5, right? So let me come here. See, DP fills example at 3 comma 5 1 best, up equals 3, down equals 2, left equals 3, and right equals 2. S of 1 is 3 comma 2 comma 3 comma 2. That is nothing but the minus 1. So star we will be considering 3 5 1 minus 1, that is equivalent to 1, star will be considering 3 comma 5 comma 1, right? So same goes with this one as well at 3 comma 5 again. So we are considering the center one, right? So center, this one is present actually, dot is present, so we'll be going with a minus 1. So 1, so we have to consider 3 5 1 minus 1 equals to 1. We are giving this one on the, we are giving this one positive value, not the negative one. So we are considering 1 here, 3 5 1, right? Again the center one at 3 comma 5 again, raise extend further due to the longer sequences, enabling another star, right? So this time if we extend this one, uh, this will extend, the race will extend, and it will lead to the this one, another star basically. So 3 comma 5, so we can consider this one up, we have another star, right? So up, only up, because down we don't have, right we don't have, and left we already considered 1, right? So another star we can consider up, nothing but here in this case it will be 2, this will be 2, right? So now we can consider 3 5 2, right? So left we have already considered, within the first step when we considered the center along with the dot, the star was present at the left 1. So up, 1 star was present, now it will be 2 along with this left. Now we have found another one, that is nothing but 2, we will be going with 3 5 2, simple. And the final one here is at 3 comma 4 s equals 1, we will be considering, we are done with 3 comma 5, right? So now we will go with the 3 comma 4, nothing but where we found s equals 1. So see here, uh, this one, this is nothing but 3 comma 5. So this star we present at the left to the dot, right? So this is nothing but 3 comma 4, s equals 1. Here we have found another star, so this is nothing but this one, s equals 2, right? So now we will consider this star 3 comma 4 where s equals 1, right? So I'll just come here at 3 comma 4 when s equals 1, star, this one we can just represent this one in the form 3 comma 4 comma 1, right? So we can represent this one with 3 comma 4 comma 1, right? Accordingly with the criteria that they have mentioned in the question, right? So then we will mark all the covered cells, means all the star are covered. We will print 3 stars exactly as same as output, as same output, sorry. We will this one, what do we call, what do we do, we will mark all the covered cells first. So here all the covered cells in the sense, uh, all stars are covered here, all stars are covered, basically 2, right? So we will print 3 stars exactly same as output, right? So we will print 3 stars exactly as same output, right? So what are the three, this one we got 3 5 1, 3 5 2, and the next one, the center one here next to it also one star was present actually. See here, we are considering this one 3 comma 4, next to it the left, this one star was present, right? So this one we will be considering 3 comma 4 comma 1, right? So 3 comma 4 comma 1, so this is fine. Yeah, we will be marking all the covered cells, all the star are covered here. We will print 3 stars exactly as same output. So this will be 3 3 5 1, 3 5 2, 3 4 1. So as we are printing 3 stars exactly as same output 3, so we'll go with 3 5 1, 3 5 2, 3 5 3 accordingly with the criteria that they have given in the question, right? So the output that we got here is 3 3 5 1, 352 and 341. See here order is different, but the output that we got here is same. We don't have to worry about the order. So see here 341, 352, 351, right? So we don't have to worry about the order. They have not mentioned that the output has to be within the same order, right? So has to be in the same order, right? So if I come to the output, but just give me a second here. Question. See here, 1 second. The first example, the output, see here, 2341352 is also correct. Or order, if we get this one, first example they have shown, this is also correct, 341 and 352. If we go with 341 and 352, only 341 and 352, that is also correct, because we have got star up and we have got star left as well, right? So we can just consider those two. That is also correct. That is actually the correct one basically. If we consider only 35, this one 352 and 341, the star left two and the star top one, that is actually the correct one. 341, this one, what do we call, 351, again we are considering along with the dot, that is also correct, right? So uh, it can consist of the multiple outputs, and the order doesn't matter here, right? So order doesn't matter as well. So output that we got is 352, 351 and 341, right? So first we got this one, second we got this one, third one. So order is different, but output is same. The output that we got is equivalent to the output that they have given for the example one within the question. So how we will implement this one via 2D DP, so that we will be seeing in the code. So this is the approach that we'll be going with. Simple, right? So we will be implementing 2D DP table. Let's see what we are gonna do, right? So we are going with a for this one, 2D DP array basically. Four things we will be considering. One is up, left, right, and down, that we know. And as I've said, we will be considering this one 2D DP, right? So this we are considering as grid man. First of all, I have drawn for the just for the sake of understanding itself here. Don't get confused, right? So now let's do one thing. Let's try to implement the same thing in the form of code, right? So now we are done with the code, right? Whatever the output that we have got is equivalent to the output that they have mentioned for the example one. And one more thing before writing the code, let's quickly discuss the complexities part as well. Right, so what will be the time complexity here? The time complexity would be big of n into m, and the space complexity would be big of n into m as well. So why the time complexity here is big of n into m? Because we will be going with a 2D DP passes here, right? So we will be going with 2D DP passes. When I say 2D DP passes, one thing is up comma left and another thing is down slash right. Sorry, down slash right. One is up comma up slash right and another one is down right? One pass to pick centers and mark the rest, and one pass to validate. Each is linear and grid size. Each one is linear and grid size. So overall time complexity would lead to this one because of n into m, as I've showed here, right? So this one because of n into m, and the space complexity would be because of n into m as well, because we will be going with a 4 DP tables, 4 DP tables plus visited array. When I say 4 DP tables, so this one up, left, right, and down. Right, yeah, up, down, left, and right, basically. 4 DP tables plus visited array. So visited we have to once suppose we have the cell, right? So some this one 6 into 8 we have, right? So we will be marking once. Suppose if we visit this one, I have just considered this one for the example sake, not exact the same 6 into 8. Just I have considered the cell. When we mark, just I have considered the grid here. If I visit this one first cell, so I have to mark this one visited. If I visit second cell, I have to mark this one as visited, right? So this one will be going with the 4 DP tables, visited array. The crosses list holds at most n into m entries in this case, right? So overall space complexity would be because of n into m. So the time complexity and the space complexity for the code that we'll be writing in the future would be because of n into m or m into n respectively, right? So now as we are completely familiar with the complexities and the approach, we are good to write the code. Let's start writing the code. So let's start writing the code here. So we'll be making use of the different utilities, whether it may be scanner, list, array list, etc. So I'll be importing here util package. So I'll just go with util dot start. So this is fine. Next, what I'll do, I'll just go with a class rocket height. So let me go with public class So this has to be small c. Yeah. Next, I'll just go with the rocket height. So let me give main man. So this is enough. I'll just go with the main. You can just go with the question name or something that is relevant, right? So let me go with main method here. Remove this one. First, I'll be making use of the scanner. So let me go with scanner. C equals new scanner. So this is inbuilt. So I'll just go with system dot in. Sorry, system dot in. So this is fine. So the next step here would be this one. We have to read n and m. We are going with the input output part, right? So we have to read n and m, nothing but rows and columns here. So I'll just go with int rows equals sc dot next int. So this is fine. Int columns equals sc dot next int. So this is also fine. The next one is scanner dot next int, right? So this is also fine. Next, instead of the next int, we have to go with next line, right? So input we have in 6 8 and we had 6 lines and this one 6 rows and 8 columns, right? So we have to check next line, next row. So we are giving sc dot next line means we have to consume end of line after m, right? So this is fine. Next, what shall we do? Let's go with the grid storage. So I'll just go with char here to arrays as we are going with a 2D DP. Uh, so this is 2D, right? So grid, 2D grid. So this is fine. Let me go with new char of this one consists of rows and this one consists of columns. So this is fine. Next one, let's go with the iteration part here. This one will be int I equals 0, I less than rows, I plus plus. So within the for loop or within the iteration, so here we have to read each row, right? So now within the for loop, let's store this one as the character array. So this will be iterated value of the grid. This one equals sc dot next line. Uh, this one we are storing this one as the character array, right? So I'll just keep here to char array. So to this one will be char array to char array. This is fine. Now let me come out of this one entirely. First, let's go with a DP, 4D DP table as I've said, right? So first let's go with up, next let's go with down, then left and right. Continuous star upwards, continuous star downwards, continuous star leftwards, continuous star rightwards. This is inclusive, right? So I'll just go with here int. So this one will be up. So this one will be new int of this one will be rows and columns. So CYLS I'll give here. Let me copy the same thing and make the necessary changes for the next three. I mean for the down, left and right. So this one will be left. Sorry, let me give down. So up, down, then left and right. This looks good. This is fine. Left and right. This is fine. Yeah. We are good now. Then now let's do one thing. Let's fill the up and left DP tables in one forward pass. So see here, we are filling. We are filling up and left, first and third one here, right? So this one. So let's fill up and left DP tables in one forward pass, right? So let's go with a two for loops here. So up and left we are considering, right? So this one has to be r equals 0, r less than rows, and r plus plus, nothing but top to bottom, right? So next, let's consider left to right. Means we are considering left basically. One more for loop here. This one will be int c equals 0, c less than columns. So this is also fine. Let me increment the c, right? So within the two for loops, let's compute for the star cells. Let's only compute for star cells. Let's I mean sorry, yeah, let's make use of the if condition here. Simple if condition. This one will be grid of RC. So this is equal to star. This is fine. Now within this if condition, we are going with the up and left, right? So this one will be up of R, C. In the iteration, we have considered R and C, right? Rows and columns. So this is fine, R and C. This one will be, let me make use of the ternary operator here. So if R equals 0, means the value of the this one is 0, then we will be going with a 1, not the minus 1. So we went with 3 5 1 3 5 2, if you remember, right? So we'll be going with a 1. uh, Else we will be going with a up R minus 1 column, uh, top to bottom. So this one will be plus 1. This is fine. So next we went with s equals 2, right? So we got one more up. When we considered from 3 comma 5 left, we found star. So we went with 3 comma 5 comma 1. We checked right, there was dot, we ignored. We checked down where there was dot, we ignored. For up there was one more star, right? So we have to consider 3 5 2. 3 5 2 for that one. If we consider, I mean, if we found one more star, then we have to go with plus 1, right? So I'm going with plus 1 here. So same goes with the left as well, similar one. So this one, I'll just write this one quickly, RC. So this one, if column equals 0 value, then we'll be going with 1, or else left R. See, I don't have to explain this one, R. So this one will be, as we are considering this one left, this will be C minus 1, overall plus 1. So this is fine. We are done. So this is stack count from row above, and the this one line number 24, 23, 24 stack count from column left, right? Uh, so dot stays at 0 by default. Dot stays at, when we are considering 3 comma 5, the grid 3 comma 5 which I had showed in the approach, so that stays, there was a dot in that place, right? So it stays at 0 by default. Just remember, left we had found star, s equals 1, we incremented. Up we had found another star in the next step, so we had incremented s from 1 to 2. So the same thing we are doing. So now we are done with filling up and left dp tables. We are left with filling down and right. So let me copy the same thing here. So this one, let me do one thing here. Oh yeah, we are going with the if condition as well, right? So let me copy this one and let me make the necessary changes here. Let me copy paste the same thing here. So now we are going with this one, down and right dp tables in one backward pass. So here we have went with up and this one, what do we call, up and left dp tables in one forward pass. So here we are going with down and right dp tables in one backward pass. So quickly write this one. Let's quickly write this one. I'll just go with int r equals not 0. This one will be, we are considering down, right? So this one has to be rows minus 1, r greater than or equal to this one 0, nothing but the reverse iteration. So I'll just go with 0, and this one will be r minus minus. So this is fine. C remains same. This one, instead of 0, this one will be columns minus 1. This is fine. C again, similar to the above, this one will be C greater than or equal to 0. Finally, this one has to be C minus minus, right? So we are going from bottom to top. This one, line number 29, line number 30, we are going from right to left, right? So again, let's carry on with the, let's move on with the further steps. Same if condition here. We will be going with the if grid of RC equals star, means only for the star cells, right? So we have to go from below plus 1, means here instead of up, let me give down first, as we are dealing with down and right. So down of RC equals uh, R equals not 0, this will be rows minus 1. This is fine. Rows minus 1, then we have to display 1, else we will be going with, again I'll just change this one with down. This one will be, instead of r minus 1, let me go with r plus 1 here. C remains same, plus 1 remains same. So let me change this one for right as well. So as we are dealing with down and right, so I'll just go with right here. This one will be RC. C equals, so here I have to give columns minus 1. So here we'll be going with 1, else we'll be going with right of RC. In I'll just change this one from left to right, so this one remains right of R. Instead of C minus 1, this will be C plus 1 again. So plus 1. So this one is from line number 32 I'm speaking of, basically from below plus 1, and this one is from right plus 1, right? So we are done with this one. So let me come out of this one entirely, right? So now let's move on with the further things, man. So we have to store the output lines xy, xy and s basically, right? So s is nothing but the star. So we have to store the output lines xy stars, nothing but 3, 5, nothing but 3 and 5 is rows and columns, right? So the grid, this one, grid number 3, 5, 3, 4, those were the grid column. This one, rows and columns, nothing but related to the grid. And S is nothing but the stars, right? So the place where we started from the center, basically 3, 5, within 6, 8. We were given rows 6 and columns 8. The center was 3, 5 we considered, and from there we started counting, right? If you remember, that is the approach basically we are going with, right? So now we have to store the output lines x, y, s. So I'll just go with list here. List of so this one will be string, within the star is represented within the string, right? So then strings, I'll just go with crosses variable here, new array list. So this is fine. The next part is let's mark the cells covered. Let's mark the cells that is covered by at least one star. That is covered by at least one star. So let me do one thing. Uh, I'll just go with Boolean. So this one will be visited equals new Boolean. So this is also fine. Rows. Oh, this one will be columns. So this is also fine, man. So let me come out of this one entirely. Now let's identify the valid star centers and mark the coverage, right? So let me go with again two for loops, right? So we have to identify the valid star centers and we have to mark the coverage. So this is what basically I showed in the approach as well. So till now we have went with the initialization and finding the center thing, right? So that's what we did. So also we went with 4 DP tables, nothing but the representation. This one, up, down, right, and left. First, we went with this one. What do we call? Uh, we filled up and left DP tables and one forward pass, and we filled down and this one right DP tables and one backward pass. So this is what we did. Now we have to identify the valid star centers and mark the coverage. So this was one of the important things in the approach part as well. So the same thing, whatever we discussed in the approach, let's this one. What do we how do I say? Let's articulate the same thing in the form of code, man, right? So I'll just go with a for loop here. This one will be int r equals 1, r less than rows. This is also fine. Rows minus 1 basically. R plus plus. This is fine. Now let me go with one more for loop here. This one will be int c equals 1, c equals sorry, c less than columns minus 1 and c plus plus. So this is fine. Within the two for loops, let me go with a simple if condition here. So this one will be if grid of r c, this one will so let me go with a star. So this is fine. So within the if condition, we have to go with the max possible size at r comma c. That is nothing but the minimum of 4 arms minus 1, right? So that's what we discussed in the approach as well, right? So I can articulate in the form of code in this way. I'll just go with the arm length here, variable name. So this one will be math.min of again I'll just consider math.min here of this one, up of r c. So this is fine. Now down of r c, this is also fine. Now again math.min of one more thing here, it would be So this one I have to close this one, right? So now let me delete one more here. So this one has to be math.min of left of r c. This is fine. And again we are left with right, right? So I'll just go with the right of r. So where did this go? It's not even, yeah, right of r c. This is fine. We are done with this one almost. Right? We have to give -1 for the whole, right? So we are just going with max possible size, nothing but s at r comma c. That is the minimum of 4 arms minus 1 for the whole, right? So I have written the same here. So now let's move on with the further steps here. If we have found a valid valid star, nothing but positive size is required here, right? So it has to be greater than 0, quite obviously. Means I can write in this way: if arm length, if it is greater than 0, then we have to store that one in the one based indexing. Means I have considered the crosses variable already, so let me go with add here. So this one will be r plus 1 simple plus we have to go with the space as well, so I'll just go with the space here, and let me concatenate c plus 1 as well, append, sorry, java. So this is fine. Now again we have to leave the space. I have left the space. Now again append the arm length. So this is fine. We are done, right? So we are just storing this one in the one based indexing one. After this step, so just give me a second here. After this step, we have to mark the center as covered, right? So we have to mark the center as covered. So this one will be visited of R C. This one, let me give true here for this, right? So this is fine. Now we have to mark the case steps in all the 4 directions, right? So again, this is simple. So let me go with for loop here. In k equals 1. So k less than or equal to this one, what do we call, arm length basically. And let me increment the k here. So within the for loop, so what we have to consider, we have to go with up down left right, all the 4 directions. We have to mark the k steps on all 4 directions. So I'll just go with visited here. So this one will be r minus k, and this one will be c. This will be true. This is fine. Now again let me go with visited. So this one will be r plus k. uh, this one will be c as well. So let me go with true here. This is fine. Again, I should have copy pasted and made the necessary changes. We are left with 2. Let's write this one instead. Let me type this one. So this one will be c minus k. Let me assign this one to true as well. The final one here is visited. So this one will be row column plus k. So this one, let me assign this one to the true. The line number 49, starting from the 49 and 52. 49 it is up, 50 it is down, 51 left, 52 it is right. So we are almost done. So let me come out of this one entirely. So why I have left this much space? So this is fine. Just give me a second here. So yeah, let me come out of this one entirely. Now we are still with left with so many things actually. What we need to do is, so basically accordingly with the approach, once we are done with marking the case steps, we have to verify every star in the grid, right? So that is covered by at least one discovered star. So that's what we need to do. So let's consider some boolean value here. I'll just go with boolean. Let me assign valid to true. Now let me go with the two for loops again. This one will be int r equals 0, r less than rows here. So, and let me go with valid as well. This is fine. So let me increment the r here. We are just traversing the rows here, right? So boolean valid equals true. We are just assuming valid uh, until found, right? So that's it. Next we have to traverse the rows and columns, right? So that's what, for that one I'm considering two for loops here. So this one will be first one line number 60 for the rows, and the second one it is for the columns. We have to traverse columns. So I'll just go with here int c equals 0. So this has to be c less than columns, and c plus plus. So this is fine within the for loop. So let me go with the uncovered star that has been found. So I have to write only one if condition. I should have copy pasted this one, two for loops that I considered earlier, and I should have made the necessary changes. It's fine. We have already typed almost most of the things. Let me type this one as well. So let me go with grid rows and columns. So this one, if it is equivalent to star, and if it is not visited, not of visited of r rows and row and column, that particular row and column, then it is valid. No, it is not valid, right? So I'll just keep your boolean value false, right? So then let's break out from here. I'll just make use of the break statement. We'll stop, right? So I mean we have to break out from this for loop. Let me make use of the keyword break. So let me come out of this one entirely. So now we are left with certain things. So if representation is possible, means if it is valid, right? So then I can just go with if of valid. Within this one we have to print the number of stars first, right? So 3 in the first line, if you remember, in the output, so 3 stars we have went with, right? So 3 stars we have went with. 2 is also valid because we have found 2 stars. We can go with the 3 as well because this one, considering the first, this one 3 comma 5 where dot was present, so that one also the star was not present, but the center one we have to consider, that one also we can, uh, right? So I have said this one in the approach as well. In the question also they have strictly mentioned in the at the end actually, basically, right? So if of valid means if representation is possible, then we have to print the number of stars. Means I'll just go with here println. So this one will be crosses dot size. So this is fine, man. uh Next, let me go with a simple for loop here. This one will be string cross. So this one will be just cross, of crosses. We are considering individual cross, right? Of crosses. So within this for loop, let's go with the xys, right? So we have to print, basically. Again, let me go with the println here. System out println, basically. Let me pass the individual cross here. So this is fine. Now, else we have written if it is valid. So if it is not valid, then they have strictly mentioned in the question, if it is not valid or if we have not found any valid this thing, valid star this one combination, right? So basically, if we have not found any star this thing, a valid combination, then we have to print -1. That's what they have said in the question. So I'll just go with println again here. So this one, system out println. So I'll just go with -1. So we have to display -1 in that place. Finally, as we are going with the scanner, I'll just go with the scanner variable sc dot close, right? So I'll just go with sc dot close. We are just closing the scanner here. Means we are done with the coding part, right? So before checking the code, this is it for the code. Before checking the code, simple, right? So before checking the code with the different inputs, let me copy paste the signature starter template, man. Just give me a second here. Let me come here. Uh, Let me copy paste here. This is fine. Yeah. Now, let me come here to the question. Let me copy the input output that we need to get here as this one, right? So here, let me paste this one and hit the run button, man. So we have some error, one error, compilation failed. Error not a statement. What is not a statement? Plus it is showing. We're just appending, right? Here, line number 64. Let me come to the line number 64. Mm-hmm. What we are doing here is dot add. So just give me a second here. Mm, just give me a second. So this is fine, right? So crosses that add. So here I have missed something, I think. What did I miss here? Yeah, let me do one thing here. We are going with a C++ as well, right? So let me give one more this one. What do we call? parenthesis here. Let me close this one entirely. So let's see whether this works. Yeah, this works. Now we have two more errors here. Cannot find the symbol sc.nextent, and sc is the variable we have considered for the scanner. So where is it? Scanner sc we have given here, right? So line number 24. mm, yeah, we have given scanner here. What is wrong here? Method nextent. So nextent, this has to be capital I. Mm-hmm. Where is it? Nextent. Yeah, this one. This has to be capital I. Again, this has to be capital I. Now let me run this one. So yeah, we are getting the output -1, right? So this one we have to get the output correctly actually. I don't know what mistake I have done. Let me give second one here. So for everything it gives -1, I think. I don't know. Yeah, yeah. Let's see. Somewhere we have done wrong. Let's check what we have done wrong here. So what mistake I have done here is this one in the line number 41. So we have to consider R and C, up R and C, right? Rows and columns we have to consider. The same thing I copy pasted and made necessary changes here. So this one also I didn't change this one to C. Instead I gave R and R itself. So this one has to be RC. So this was the main mistake, I believe. I don't know. I think now this has to work. Yeah, now we are getting the correct output, right? So we are going with the second input here. 3 2 2 1 3 3 1 3 2 2 1 3 3 1 3 4 1 3 4 1. We are getting the correct output. For the first one, we have to get 3 4 1 3 5 2, and this one, right? So yeah, this one is also correct. We are getting 2 3 4 1 3 5 2 basically. So this one in the question they have strictly mentioned. See here, 2 3 4 1 3 5 2 is also correct, right? So this one also we can go with, or as I've showed you in the approach basically, right? So we can just go with 3 5 2 3 5 1, this one basically 3 5 2 3 5 1 3 4 1 as well. So this is also correct one, right? So order doesn't matter. So this one 3 4 1 3 5 2 3 5 1 is also correct, right? So we can have multiple outputs for this particular this thing input, right? So this is fine. Now let's check with the third one. For the third one we have to get -1. Let's see here. Let me run this one -1 please. Yeah, so this is working correctly, man. This is fine. Now let's go with the last input. So this has to give us -1 as well. Now, yeah, we are getting the -1 for this as well. So the output is absolutely correct, right? So for the inputs that they have mentioned in the examples within the question. So this is fine. Now we are done. We are almost done with the question. Let me copy this one. Let me hit the submit code here. Let me choose the problem. This is E1, right? So let me select E1 from the drop down. Let me paste the code over here. Submit. Let me hit the submit button. So let's wait for some time. Let's wait for some time. So here, yeah, we have purely went with the 2D DP here. Nothing but 4 DP tables, up, down, left, and right, and 2D DP we are making use of, or we are going with the 2D grid as well, right? This is fine. Yeah, this has to work, man. Let's see. Yeah, you can clearly see here the verdict that we got here is accepted. Means the code works absolutely correct for all the test cases, right? So the code works absolutely correct for all the test cases, right? So this is one of the simple problems for the this one 2DDP, right? So for making use of the 2DDP basically, right? So we have successfully solved this problem. I hope the solution part is completely clear along with the approach and the complexities part. For now, this is it. Thanks for watching, guys.